All right, guys, so welcome back. This is question number 2. Now, this question is about sodium and chlorine, okay? So just go there, sodium and chlorine. Figure 2 shows the position of sodium and chlorine in the periodic table. So we got the periodic table here, Na and then chlorine. State one difference and one similarity in the electronic structure, right? So your answer needs to be referring to this of sodium and chlorine. So one of the difference is that sodium has 1 electron in its outer shell, chlorine has 7 electrons in their outer shell. Okay, so now we're looking at the similarities. Now for these ones, it's only 1 mark for the difference and 1 mark for similarity, but I'm gonna add a few similarities so you can have an array to choose from. Okay, equally here, this could be just the 1 mark, yes, but I'm gonna give you a number of different answers over here for the similarities. So one of the things we could say is that they both have the same number of shells because they both, this is period 1, period 2, and period 3. Okay, so most of the time a lot of people get this or miss this because this first period actually only has 2 elements, and this is going to be your period 1. Then you have period 2, period 3, and period 4, and the periods tells you the number of shells. Okay, so in this case they both are in period 3, so that means they both have 3 shells as a similarity. Okay, that would be their 1 mark. Another mark could be that they both have 2 electrons in the first shell, they both have 8 electrons in the second shell. All right, so there you have it. That will be your answer for question 2.1. Now let's move on to question 2.2. Now, sodium atoms react with chlorine atoms to produce sodium chloride. Describe what happens when sodium atoms react with chlorine atoms. Write about electron transfer in your answer, okay? Now, to get on with this, we're gonna have a look at the bond technique, okay? And that is BUN. So we're looking at BUN. B will stand for box your command words. So in here, they're asking us to describe what's happening. The U stands for underline. Okay, so when we're gonna underline here is the information. So it's telling us the sodium plus chlorine produce sodium chloride. Now they're asking us to describe what happens to sodium reacts with chlorine, but you have to write in terms of electron transfer. Okay, this is where you want to go. A lot of people will say sodium reacts with chlorine and they produce sodium chloride. They could do it in those words, they could do it in different words, but essentially what you're doing is that you're just repeating what the question is telling you. You're not actually answering anything. Okay, so for this, let's break it down. Okay, now we know that sodium is going to be in group 1. Okay, that means it's got 1 electron in its outermost shell. And we also know that chlorine is in group 7. That means it's got 7 electrons in its outermost shell. So what would happen is that sodium is going to give away 1 electron to chlorine, and then chlorine will become a negative ion and sodium will become a positive ion. Okay, now there is something very simple that I do when I tackle questions like this, and this is the following. Okay, well, I'll tell you in a second. So the N, before I forget, the N stands for number of marks. So when you're talking about that, you need to find a way to distribute the answer to cover 4 marks. Okay, so if you're talking about sodium, 2 marks have to be regarding sodium and 2 marks have to be regarding chlorine. Okay, so we're gonna split it even. So the first thing you want to do is that you want to identify the metal and you identify the non-metal because this is an ionic bonding. So what we got here, first of all, the metal here is going to be sodium and the non-metal is going to be chlorine. notice that they don't have a plus or a negative symbol because at this point they are atoms. Atoms don't have a charge. They have the same number of protons and same number of electrons, okay? Now, because sodium is a metal and metals are always going to give away their electrons, chlorine is a non-metal. Chlorine is always going to accept electrons. This is what we got to do next. So sodium has lost 1 electron, chlorine has gained 1 electron. So now, because sodium lost something negative, sodium is going to become positive, okay? But by how much? Well, because it lost 1 electron, it's going to be now positive 1. And then the chlorine, because it gained something negative, chlorine is going to have a negative charge. But how many negative charges? Well, just 1 because it only gained 1 electron. Okay, so there you have it. Now this is going to be a cation, and this is going to be an anion. Okay, there we go. So having this structured, all we have to do is put it into words, okay? Now this here will be 1 mark, 2 marks, 3 marks, 4 marks. Let's go. Right, so there you have it. That is your answer. Sodium loses 1 electron and it becomes a positive cation with a charge of +1. Chlorine gains 1 electron and it becomes a negative ion with a charge of -1. That is where your 4 mark is going to be. Na loses 1 electron, that will be 1 mark. It becomes a positive cation with a charge of +1. That's going to be mark number 2. Chlorine gains an electron, mark number 3, and chlorine becomes a negative anion with a charge of -1, and that's going to be your 4th mark over there. Easy peasy, okay? Now let's move on to the next side. Okay. Question 2.3. The reaction between sodium and chlorine is an exothermic reaction. Complete the reaction profile for the reaction between sodium and chlorine, okay? Now here is the clue. This is more or less irrelevant because sodium and chlorine, well, those are the reactants really, but the clue here is that the reaction is exothermic, okay? So what does that mean? It means that the energy given out is going to be bigger than the energy taken in. Now, how do we do this? Well, we got to take in mind that in an exothermic reaction, you're going to see a couple things. The reactants are always going to be higher than the products, okay? So if this is energy, the reactants have a high energy. So for instance, if you have any fuel, it has a high amount of chemical energy stored within there. And once it's burned and turned into ash or smoke, it's going to have a little bit amount of energy. Okay, so we're going to start with that. We're going to draw a line at the bottom, and this is going to be your product. You can think about it as wood having chemical potential energy higher than what ashes do, okay? Because once you burn the wood, it turns into ash, and the ash has little energy value, okay? Now, all we have to do now here is give us a slope and go all the way down, okay? This here is what's telling us that the reaction is exothermic. Now, if you remember, this is only a 2-mark question, but sometimes you'll be asked to label the activation energy. So let me see, complete the reaction profile. That's going to be 1 mark. That's what we've done right here. Just in case, we're going to go from the line of the reactants. You're going to do your dotted line, and this here, that is the energy in. That's your activation energy. And from the top, going down to the products, that's going to be your energy out, okay? So let me label those down for you. Activation energy and energy out. Now, another thing that you may be also asked is to label the enthalpy change, or the difference between them, or the change in energy. And you can imagine that that is the energy in, this is the energy out, and up to this point here, the energy in and the energy out are going to be the same. So whatever you got left is going to be your difference in energy. So from this point to this point, that's your energy change. And also is known as energy enthalpy. Okay, so from here, we're going to move on to the next question. Okay, so that was question 2. Now click on the next video where we're going to be going through question number 3. Right, so there you have it. Quick time revision. Like and subscribe, and I'll see you next time.